and we as a host, of course. There's most to the issues with the presentations, but it's a pleasure to be a host. Today we have reached more than 150 people coming today, so that's good. And there's even a waiting list, so that's good. We have reached the target, or at least my own target, for 150. We're not going to grow it further on. I think 150 is enough. So that's good. I want to apologize for one thing from last year, and that was I promised you when you come back this year, there's going to be a new building in this place. I'm sorry for that. But to make it up for you, is that we are not going for the original plan of like building inside and keep the outside structure. We're actually going to tear everything down and we're going to build a 3-story storage building, 2,000 square meters. And so that's our building applications into the municipal now, and all applications for all ones for this building are there. So hopefully the next time we're coming, we have even more for you to show. And the good thing about that, this building here is also be connected to the main building with walkways from each floor, so it's going to be very practical using the building for storage. Also last year, we did say that we are introducing Gen 6. As you will see on the banner, I have now crossed over the introducing because now it's actually here. We have produced quite a lot. There are more than 20 systems now out in the market being operated from day to day. We have 50 under production, so things are moving fine on that area. Jumping a little bit back, maybe I can said there's no planned either fire alarms or anything. So of course, if the alarm goes, stay close to me. I will be first out. So that's fine. And then for ladies, there are toilets inside for ladies. And for the rest of the people, I'm not going to differentiate any more general than that. The rest of the ones that are not ladies have to do it outside. Okay. That's good. Yeah, we have grown quite a lot the last years. We are continuing to grow. I will actually get Dave Curry, the manager for our office in Aberdeen, to come up and say something. There was another presentation we did last year from Freddie, and it was Adobe. I think he had a very interesting sentence at the end of, okay, now what are we going to use it for? That Adobe, that big charger, has now actually got the global patent approved just recently. And we see more and more very interesting applications for it. And there was a pilot project going just in probably 1 month ago, sorry, in 1 month for that. So, yeah, that are some of the things that happen in RTS. We have a lot more. Come on, ask. David?
I'm done. Does this work? I'll use this. Hello. Hi. I'm David Curry. I'm Managing Director of RTS in the UK. This is my 3rd SID as part of RTS. I used to come here many years before as a principal and a supplier to RTS. Now I'm actually part of the family. First thing is to say how fantastic it is to see the number of people here, more numbers than we've ever had before. It is the original and the best innovation day from any company that I've been to, and I love coming back to it. Aberdeen has grown significantly over the year. Since December last year to October this year, September this year, we've doubled in size. And the plan is next year when I come back, we'll have doubled in size again. We're going to look at overseas bases. We've signed some partnerships with some company Southeast Asia, and we very shortly will be doing something in the United States of America. So watch this space. RTS is going to grow. It's going to be very, I think, a really good road for everybody to be part of, and thank you for your business. Enjoy your day.
Okay. Do you hear me now? Yeah, right. So this is a bit of an aside, and I'd like to thank RTS and NOS very much for giving me the opportunity to say a few words about a very special person. So this is not in the normal run of things, but yep, a good friend and a very fine surveyor who passed away this year. I think some of you here have known in the past, Mikko Nisa. So yeah, first off for the day, hopefully won't put too much of a somber note on things, but it is very good to let people know about this man's life and the challenges he faced and what a great guy he was. Didn't realise I'd be up first today, and not really a keynote speech, but his life is definitely worthy of the subject of a keynote speech. So Mikko Nisa was one of a kind. He's a noteworthy hydrographic surveyor. On the 2nd of June this year, Mikko logged off for the final time. He had a fatal heart attack at the age of 44, an incredible injustice as he had spent the last 4 years literally getting back on his feet after suffering from a brain hemorrhage on his 40th birthday. He was a remarkably capable surveyor and honestly one of the funniest Norwegians I've met in my time in the land, which is a pretty hard gig to hold off. He came from the south of Norway, down in Lillehammer, born and raised as a young man. That's where he spent most of his days, until he decided to head up to the north of Norway, when he did his national service. But prior to that, he headed over to the United States for one of the years of his Videregående school. But when he's back in Norway, he studied a master's degree in navigation and electronics. And then following this, he found his way back to the sea, and he took a job with iSurvey. And so, yeah, back before it was reached, and I've been informed by the guys at iSurvey that there's a number of key people in his development, his learning to be a surveyor, Sven Karek, Kenneth Lavisher, and Tormod Urka. Apologies if the pronunciation is not right there. Yeah. They brought Mikko into the world of survey and global travel, working in the USA, North Sea, Mediterranean, China, where he was introduced to the nightlife and the food in Asia, which he really became fond of. A quote I've been provided by some of his old iSurvey team: Mikko was a smart and forward-leaning person that everybody loved being around, including the survey team, marine crew and clients. Mikko was indeed a serious surveyor and quickly became a resource within iSurvey. He was an intelligent and fast learner with a glint in his eye, and he could always make you laugh by offering witty remarks on anything and everything, all the while peering at you over the rim of his glasses. He completed a lot of training courses for iSurvey and the staff and whilst working for IVA. And I thought the junior surveyors really appreciated his teaching. So yeah, that's him at iSurvey. So in 2011, he headed down to the south, to the Philippines, and started a life down there. And it was during his second trip that he met his wife, Angie Rose. And her and their daughter, Julianne, really changed Mikko's life. When Mikko left iSurvey, he started a couple of companies, first Valberg Consulting, in which he hired himself out through and brought in contractors. Alongside this, in 2015, he started a company, Foss Abyss, in Cebu. I've been told the same guys still employed within the company as when he formed the company. I met Mikko when he decided to head back up north for a stint, and I brought him into the team at DOF Subsea as a project surveyor. In this role, he was rock solid. He proved to be one of the main hydrographic survey knowledge bases we drew on for a time. He kept me on my toes, and it was a lot of fun working alongside Mikko, constantly cracking jokes in his characteristic style, holding a straight face. Since we both left off, I've stayed in touch with Mikkel over the years. He returned to Asia, working with his team. He also took on the role of running IVA's support office in Asia. Ola Christiansen from IVA has informed me that as a client of IVA, Mikkel was always brutal, but he was fair and professional. And that one of the reasons IVA teamed up with him was this, and with his company in 2016, when he built IVA's support team in the Philippines and helped IVA establish a 24/7 support service. In this, he focused on making things better, and at the same time, he was very relaxed and a joyful colleague and friend. In 2019, he was celebrating his 40th birthday when disaster struck. Mikkel suffered a brain hemorrhage in a restaurant. He spent the next 16 days in a coma and only 15% chance of survival. He did pull through though, and when he awoke, he was unfortunately blind in one eye and partially paralyzed. He was only able to communicate through writing on a chalkboard at this time. He was flown back to Norway on a stretcher, from where he continued to battle for his life and for medical support from the Norwegian government. The next years were tough for Mikkel. I don't have time to go through the details here, but there are press articles online which detail his struggle. Mikkel worked hard to relearn the basic functions of being a human, to walk, to talk, and most importantly, to crack jokes. I was in contact with him during his recovery, and not once did I hear from a broken man who was down on his luck, struggling to rebuild his life. I heard from a positive warrior of a man, and in not lying down and giving up, he characterized the lines of Rudyard Kipling's poem printed on the screen here. If you can meet with triumph and disaster and treat those two imposters just the same. For those of you familiar with Monty Python, his attitude reminded me of the Black Knight from the Holy Grail, totally unwilling to acknowledge injury, but just using it as a source of humor, focusing on a way forward. Luckily, Mikkel didn't get as far damaged as Black Knight. Like Mikkel, I was once a soldier, back in the days when I had hair. Some of my former squadron mates have since been blown up in Afghanistan and Iraq, and they've lost legs. But they have not given up, and they have faced the horrors of injury, picked themselves up, and as the motto of the unit I was in, the Royal Engineers, improvise, adapt, and overcome. Mikkel demonstrated that same fighting spirit as an indefatigable Norseman in his battle with injury and disability. The fighting spirit of the boy soldier he was in Troms never left him. Once he was able to walk, he found a way back to survey vessels, first on a wheelchair, then as you see in this picture, a semi-paralyzed man sneaking away from his wife, I was told, to oversee a mobilization of a small vessel. He actually swam to the vessel when she wasn't looking, and he was helped on board. Again, this brings us to lines from the poem here. If you can force your heart and nerve and sinew to serve your turn long after they are gone, and so hold on when there is nothing in you. Mikkel was cremated in the Philippines. His family brought his ashes back to Norway and held a ceremony for him on the 15th of August, which would have been his 45th birthday. His business is now being run by Angie Rose, who is holding the fort until their 16-year-old daughter, Julianne, pictured here, will take over. She is determined to keep the business going in the memory of her father. Some of you here today had the privilege to know and work with Mikkel. It is far from my intention in giving this speech to start the day on a somber note. I'm sorry for that. For those of you who did not know this man, I'm glad to present his story to you. Mikkel was a humble yet determined man, who I am sure would not want me to be making a fuss over his passing today. I've taken the trouble to give you this speech today as I fully believe the story of one of Norway's finest hydrographic surveyors should not be left untold. Final words stolen from Dylan Thomas, in keeping with Mikkel's attitude to life and death. Do not go gentle into that good night. Rage, rage against the dying of the light. Fair winds and following seas, my old friend. Thank you.
Thank you very much, Al. It was very touching, very I didn't know Miguel myself, so it was good to find out a little bit about the history of what we are essentially in this business, a very small and close-knit community of surveyors. So I don't intend on doing more eulogies at this event, so nobody's allowed to die on me anymore. That was banned. I did that a few years ago and it's not recommended. So, but thank you very much, Al. That was very touching. Just to lift it up a little bit, I'm going to take 5 minutes. We're already behind schedule, but we'll try and get a little bit back on that. We will, I'll explain, potentially get back on track shortly. I'm Stuart Duncan. I'm the chairman of NOST. I've been chairman for the last 3 or 4 years, and it's a pleasure and a privilege to be supporting the offshore survey discipline and skills here in Norway. We do it with the kind support of our sponsors, all of which you can see on our screen, and we've gone up at least 10% in the last 2 to 3 years. So if there are companies that are thinking that they would like to be part of it, there's a lot of advantages, and we can go through that. We just need to talk to any of the team who are present here today. We are 3 here, and we are looking for some additional people. As I mentioned, I'm the chairman. We've got Ricardo here, who's co-chair and treasurer. Derek is unfortunately unable to attend, and neither is Odd. Elizabeth is over on that table. Don't need to stand. And we've got Armand, who's a brand new recruit from DOF. And we are looking for additional help. These are quite challenging to put together, these events. It's always a pleasure to talk to people, but we have to try to get presentations, try to come up with a theme, do something different. And I'm going to come on to a little bit about that in a moment. But if anyone would like to help us, please talk to one of the 3 of us here, or 4 of us here, and we will entertain some conversations with you. So I wanted to use a little bit of time because I know that this is a pretty cool and very broad base of people here. I'm talking about what we decided to do last year. After the annual dinner and very hungover in Stavanger, we thought we'd take a slightly different direction in 2024 and focus a little bit more on newcomers and new people into the business. There's a lot of old names circulating around at the moment, certainly within survey. We thought that we really needed to make that push into the universities, colleges, and just try to get some new blood into the industry. So last November, we sat down, came up with a bit of a plan. We sat the start of the year, the first presentation followed a lot of what we'd done previously to that. But then in April, we had and joined forces with the University in Stavanger to do Subsea Days. So we invited a lot of the sponsors from NOST to come along. We got about 12 to 13 of them, and we took that and our stand, various presentations of our companies to the University of Stavanger and had Subsea Days 2024. That was a really big success. Probably the only thing missing there was students, but other than that, it was a very successful event. So we're trying to get more students along to that next time. It was unfortunately a little bit missing the key elements. But I think a little bit more marketing. This will gather pace. The intention is to do this on an annual basis now. So I would recommend it's not just going to be wholly for not sponsored companies, but I think we'll open it up to others as well. So if you're interested and keen, either contact someone on the NOS board or either reach out to UIS Subsea. They're a great bunch of students doing a lot for this in this industry as well. But what we also did, and we took this up to Bergen as well, at Høgskolen, and we had Subsea Days in Bergen. The weather was absolutely sensational that day, so I'm sure that everyone turned up in shorts. You'll see that in a photograph in there. This is the first time we've ever done anything like this in Bergen, and it was awesome. It was a great time. All the companies that were down in Stavanger came along as well. So you can see a little bit. There's Fugro, and we've got, no, that's not Fugro, that's Deep Ocean, that's Fugro. And yeah, we just had a great time. And this was very well received, not just by the land survey students in Høgskolen, but a lot of the other students studying other subjects. So absolutely, we're definitely going to go and do that again next year. What also happened, and this is really what I wanted to talk about, was we have been talking to Høgskolen about a survey course, an offshore survey operations course. And I'm going to show you just a snippet of the syllabus that we have presented to Høgskolen last Friday, together with Fugro and Seabed. And the intention is to have 6 hours a week, 14 weeks, and this will be 10 studiepoeng. I can't even know what that is in English, but I know what it is in Norwegian. But this means that potentially next autumn, we will have the first survey operations course in Norway, as far as I know anyway. Someone can obviously tell me otherwise. But the fingers crossed, there's very much a lot of support coming from Høgskolen for this. I firmly believe this is going to happen. But the key to it is going to be from you guys, from business, the industry. We need companies to come and present. Each company takes 6 hours each week for 14 weeks, and we have a syllabus, but we've just got to assign a company to help us get across the line. I don't see this as a problem. All these companies have already committed their time and resources and equipment to it. So we just want to find some more. We'll try to collate that information and then we'll get going. So I would like to hear from anybody who is keen to support this. And I think it's in everybody's interest to get on board, because this is, the momentum is nicely going, but it needs to keep going. And we're all a little bit fatigued from being in the industry, but this is and all the work that we've got at the moment, but this is the key to our future, in my opinion, in Norway anyway. Luckily in the UK you've got Plymouth, Newcastle and Glasgow, various places, but here, this is one thing. One thing I would say, this is not going to be exclusive to just students at Høgskolen in Bergen. We are going to offer it to companies to come in as well, to be able to take a survey course. Field trained obviously don't want to hear me advertising this, but this is very good, I think, for the Norwegian market. So here's the rough, and you're not going to read all this in 2 slides, but we've got a very comprehensive syllabus over 14 weeks. I've spent a lot of time with Rich Lear putting this together, input from some of the companies that answered my email at the end of the summer. So yeah, this has got huge potential, and I'd like to hear from anybody over the course of the day who'd like to get involved. So in advance, thank you. But on with the rest of the day and the rest of the year. We've got another not event plan in Bergen. Like I say, we haven't got a theme because we haven't got too many presentations. That was the status about an hour ago. I think we've probably got 2 now from just being here. So it's another worthwhile event to be here and network. Then the annual dinner, or piss up, I think is the best way to put it, is and it's pretty much going to go the same theme as we did last year, but we're going to go back to Bergen and Moy. We weren't quite satisfied with what happened last year. It was good, but I think there was room for improvement. Bergen and Moy is the last year we're going to be able to do it. They're going to change name, and something else will be in that place. So a fitting way to go back to Bergen and Moy, where I think a lot of us have had a lot of good evenings. So I'm thoroughly looking forward to that, because I'll be presenting as well. And then for next year, of course, we will be putting more dates up soon. But we need some assistance. So like I mentioned, please come forward and show your interest if you want to support us continuing the good work of NOS. Okay, so on with today. We had a slight change already. Runa, unfortunately, is in hospital. He will be coming, but he's a little bit delayed. He messaged me before, just when I came on stage, to say he is still waiting for it to be seen. So we're just going to shove all the presentations up. It's a bit unfortunate because his presentation was a good introduction to the theme, of which I can't remember the theme completely now, but it was along the lines of seabed intervention. So on that note, I'm going to just hand the microphone over to Lindsay from Soil Machine Dynamics.
Yeah.
No problems there. So yeah, I would like to wish you all a very good day. Like I said, contact any of the people from NOS if you'd like to support us. And on that note, I'll give it to you. Would you like to?
Thanks, you. Perfect. Just a presentation of that and then get started. So, for those of you who don't know about soil nutrient dynamics, or that SMD, the company has a heritage in seabed intervention. The main sort of focus of the company right now is manufacturing ROVs and trenches. We've recently moved into the design and manufacture of electric ROVs. And we've also, along with myself today, as one of my colleagues, Stephen Wilson in the audience there, who's looking at the future of autonomy as well. So what I'm talking about today is Artemis, which is another technology which we've developed over the last 6 years, and which is a product which has been designed for cable and pipeline tracking and survey. So, just to give a bit of an overview on why we were looking at this as a potential product and market, what we found over the past year is that cables are now becoming a more critical asset within the subsea industry. So that's partly down to the growth in the offshore wind market, but also to do with the growing need for subsea electrification. As a method to protect these key assets, what we've noticed as an ongoing trend is that there are increased spiral depths required for these utilities. And this is in order to maintain a reliable structure and carry on ongoing production, minimise any key risks from damage. There's various things which have led to this. Part of it is, which has both enabled and led to this need. And part of this is to do with the need for protection of the asset. So due to human activities, such as fishing activities, things like that, a lot of these utilities can get damaged. In addition, there's environmental considerations. So in areas where there's shifting sandbanks, things like that, the cable, when buried at a shallow depth, can be exposed. Technological advancements, so there's been advancements in both the trenching capabilities, the materials used, which has allowed the cables and the pipelines to be buried to these deeper depths. In addition, we're seeing more and more that is built into the requirements. So there's environmental needs that are now meaning that the cables have to be buried deeper to prevent sort of the impact on the marine life, the ecosystems, and also stricter regulations which are actually enforcing this. Economic factors, so we're now seeing from a lot of the insurance companies as well that this is a key driver for them to have the assets protected and buried in deeper depth. So what that means as far as cable tracking and survey goes is it leads to a number of challenges with the existing capabilities and technologies. So for some of the existing technologies, we have range limitations. As well, there are some technologies which do have the capability to reach these ranges, but have a very high cost associated with them, and also need specialist personnel for both the tracking itself and then for both processing. The data accuracy, so a lot of the technologies that can be used for cable tracking and survey are working towards the maximum capacity and towards the maximum range, which has been to accuracy issues with the data. The ability for real-time monitoring. So in this case, this is a key driver we're saying from clients, and they want to actually be able to see that data live and have confidence in that data, rather than needing to send it away for post-processing, not having a feel for what's actually happening at the time of the survey. Multi-pass burial and remedial burial. So part of this, now that we're going to deeper depths, this is a necessity. Having confidence in the position of the utility of the cable that's being laid at the time is key when loading the sort and things over those products. One of the things as well, that just to note that we are seeing an increase in is the requirement for the reburial of live cables. So where this was always the case that they would definitely turn the power off, stop production, and then rebury the cables. Now we're seeing that because of some of these improvements in the tracking capabilities, that the system can be left live and the product used to perform the operation. So what this has meant for us is that fix and focus on the developments with Artemis. So that is our cable tracking and survey technology. So with Artemis itself, that allows both passive and active tracking of the cables or pipelines. I'll give a bit of an overview initially of the passive system. So there's two main modes of operation for the passive system. The first being Autonomous Passive Live. So the system here, you can see this on the image there, it's mounted, with some sensors mounted to the ROV. What this is doing is it's used to track live AC or unipolar DC cables. So with live AC cables, what the system's tracking is the imbalance between the phases. And with unipolar DC, it is tracking the residual ripple which is left from the BHG AC to DC conversion. Unfortunately, this mode of operation here can't be used for bipolar DC because it's cancelled out in the return path. One of the main benefits of this system is it's flexible, it can be mounted to both ROVs and trenches, and it allows production to continue. There's no need to stop the ongoing production, or there's no need for intervention at the ends of the cable, unlike the turnout system, which would require access to the cable ends. As far as the capabilities goes, there's a detection range capability up to 10 meters, and that's from sensor to utility. So the depth of barrier itself doesn't matter. So it is all just to do with that range from the sensor to the center of the utility itself. The system here, we've got an excellent track record. It's been utilised for a long period of time. It's based on well-established modelling of the magnetic field. So the system's out there readily available. One of the benefits as well is the system, as I've mentioned, it can also be mounted to trenches. In this case, it can be used for geo tracking, which I'll come on to in a bit more detail as the presentation continues. But basically what that allows is to have sensors both fore and aft of the vehicle, and the sensors at the rear allow you to have confidence in the position of the cable so that you can lower the source over the product and know exactly what the cable is. So just coming on to the autonomous passive tone system now. So this functionality-wise is more similar to the TSS 350, which a lot of you guys will be familiar with. It has the same hardware configuration as the live system above, and also has the same range capabilities of up to 10 meters. There's a guaranteed performance allotted for the cable size. What is required in the case here, though, is the power needs to be turned off, and you need to have access to the ends of the cable in order to apply that tone. The sensors themselves can detect a whole suite of frequencies, but we recommend using a lower frequency due to the signal attenuation. Again, this system here has a good track record. It's used by a lot of the main operators. So yeah, that's an overview of the tone. But I'll come on to the active now. So this is one of the key developments with this system. So the aim of this is for when there's a cable without an existing power or tone, and you don't have the ability to apply the external tone to the cable ends. So if it's dead, damaged, or it's just been installed, then this system is the most suitable. So with the active system, again, it's the same hardware as previous. You've got the same sensors at the front of the vehicle there. But what you also have now is the addition of this antenna at the rear. So the antenna itself is used to produce a 3 kHz magnetic field, which then induces a current on the armor package of the cable or on the pipeline if that's what's being tracked. One of the key aspects of this system is that it's with it inducing the signal and then measuring the magnetic field strength. One of the key aspects is having a good path to Earth. So having the armor package and inducing on that while it's in contact with the seawater creates a very strong signal strength. With this one, obviously the key benefit is that you don't have to have any existing power or signal on the cable to be able to track it. The detectability range is up to 5 meters, which is a lot greater than the comparable technologies out there. Again, it's lightweight and flexible fitting, so it can be fitted to both a range of ROVs. We've also fitted to some AUVs and trenches. One of the benefits of the system as well is that with having the same hardware, you could fit the whole system and then just change at the top side between the operating modes. There's no need to retrieve the vehicle between operations. The image at the bottom shows the system being mounted in the geo trenching mode, which was mentioned previously. So this can be used for both the active and passive system, so whether you have the antenna or not. Again, has the sensors for and aft, which allows those swords to be lowered over the product with confidence. You're not going to damage the cables. So the next slide here, this is just to provide a bit of an overview of the flexibility of the system, along with some of the vehicles it's been mounted to on various trials and operations. You can see that there's a few different work-class wrenches. Also, it's mounted to the ECFE on the bottom right there. And again, it can be, we have a standard frame which we would offer, but again, it can be bespoke to any vehicles. With regards to the main components, the system itself consists of 3 sensors. It can operate on a minimum of 2, so there is a level of redundancy built into the system as well. With the sensors, they have sensitivity range from 10 Hz to 3200, which means that the same sensors can be utilized for all 3 operations and focusing on the different frequencies. The EPOD, the main CPU for the system, so that's another piece of hardware. And then the antenna, which is designed to output that frequency between 2900 and 3100. So just to give a bit of an overview of the user interface as well for the technology, it's a fairly simplistic view. It's easy for both the operators and the spares to follow. The model itself is a predictive model-based approach, which is used to then validate the linear path of the cable. So the system itself is looking for a linear magnetic field. So hence why it's used for power cables and pipelines. It's not used for vessels and things like that. The view here you can see is over to the left-hand side. I'll just so over. So over here on the left-hand side, it's that is showing the actual position of the cable, and the blue line you can see here is the cable itself or the pipeline. So this is a live feed. It will show real time where the position is. It's not a waterfall feature, so we'll move around at the time as well. Over to the right-hand side, you can see here this is the main seabed level and the depth of the product. Blue point in the center being the product. Along with that, you will be able to see the signal strength, also health indicators for all your sensors and your antenna, so you know exactly what's going on subsea. As well, the green triangle is a center point of the vehicle, so you can know exactly where you are relative to the cable. As well as that, what we found to be very beneficial, which we've developed over time, is quality control indicators. And this allows you to have confidence in the data that you're showing. So this is for both the offset, cable position, and the depth of area. So you can see here that it's the 2 green ticks. It's the system is based on a traffic light system, so we have green, amber, and red. So if the data falls within 5% of the range, then it shows green. Outside of that, it's amber, and then once it hits 10%, it shows red. So this will just give you an indication as to whether you need to move back with the product, or if how much of a system, how much of a reliance you can have in the data that you are obtaining. Another feature in this as well is having different abilities to input different sensors and things. You can also output to survey software. So we've had clients outputting direct into Quincy for their survey tools and other systems as well. What allows you to output a string of data, you can also output the same string of CSS, and then that can be used directly into the system. So some of the main system benefits which we've tried to address with the development of Artemis is, I'll just run through them now. So there's the real-time tracking and depth of burial. So again, this removes the need for post-processing data. That was one of the key aspects that the clients are wanting from this product. Increased detectability range. So for the passive live, in comparison to many other technologies, there's an increased range of up to 10 meters. Or the active system is up to 5. Flexible system, it can be applied, the same hardware is used across the systems, and it can be applied to different vehicles. The only difference between the active and the passive is that inclusion. It's adaptable solution, so across the different modes of operation, you can look at a variety of different cable types, both with and without power and damaged cables, then be able to track them. When utilising some of the modes, the cable survey can take place without the need for interruption, so the power transmission can continue, which obviously saves the client a lot of time and money with any downtime. The data, as mentioned, can be fed into the external software. In addition, the data can be fed back in to be used for closed vehicle control and have been mounted on a 4.5 sensors on a treasure. One of the benefits of having this increased range, that means during an operation, so I'll come on to this in one of the case studies, but during the operation, having the ability to fly that vehicle higher above the seabed means that the survey can be done a lot faster as well, because with the range limitations of, say, some of the other comparable technologies, you're almost having to fly the ROV at a very slow speed, very close to the seabed. So having this increased range means the vehicle can be flown much higher, and that obviously increases the overall survey speed, which over a long distance would be very beneficial to the operator. So just to give a bit of an overview of the system, I'm going to talk through a few of the case studies that we've done earlier on in the project to show some of the key aspects which we've addressed here. So this image here, this was a survey that was done on a live HVDC cable, which needed to be kept in operation. So it was key that there was no way that this could be, the power could be turned off and a toll applied or anything like that. So that's why Artemis Passive Live was key for this particular operation. So initially, there had been a survey done with a TSS 440 prior to doing the survey with Artemis, but because of the range limitation and some of the depth of barrier across the length of the product, it was just dipping out of that. It was just going past that sort of 1.2 towards 1.5 meters, which was just taking it out of the range. So there were points in the data which were missing. So Artemis Passive Live was then mounted and to track the ripple from the AC to DC conversion. So because of the live system having that increased range capability of up to 10 meters, this meant that the ROV could be flown much higher. It was flown with a 6 meter offset, and it was flown at a speed of 1.5 knots. So this allowed the survey to be done and also compared against the data where the TSS was able to detect, and it was done much quicker over the overall length of the system, but also allowed those deeper parts to actually have the data to detect. So the main aspects from this were both the fact that you could have a greater range, fly at a faster speed, but also where the range dropped out of the capabilities, Artemis could detect it. So now coming on to this other survey here, this other case study. This was a live HVAC export cable. It was key again that this remained in operation throughout. So one of the problems, this was Yandernul, one of the problems they were having was that due to shipping sandbanks was parts of the cable which didn't meet the required depth of burial, which was a minimum of 3 meters. So what was done in this case, because of the fact it was an HVAC live cable that needed to be maintained in operation, initially Artemis was mounted to a sled, and it was shallow water, and the part of the cable that needed to be very well identified. And once I had confidence in the system, then it was mounted to the Yandernul's amphibious trencher, which you can see in the picture there. And then the reburial was performed. So part of the key aspects which made Artemis critical in this operation was that the burial depths were between 2 to 5 meters, which took it out of a lot of the comparative technologies boundaries. And also, with it being a reburial op, this allowed the client to have confidence in the position of the cable when lowering the source. This is just to give a bit of an overview as well, because obviously a lot of the focus on the presentation has been on power cables. We're also interested in tracking and setting fibre optic cables. So on a recent job we've done with Geocratic, they have been utilising it for multiple operations. For it is the passive system, so they're applying a tone, but we're tracking the fibre optic cables. So the operations that we've shown here, which is more recent ones, were done just off the north coast of Egypt and in the Red Sea. So one in the Red and one in the Red Sea. The client is very happy with it. They own the system now as well, and they have, during this survey here, it was a multi-pass operation, so they had the confidence to keep running with this. They also said in areas, which isn't the case in this image, but in areas where the visibility was really poor, the tracking was easy to follow and just to show that it's not just focused around the power cable side, we're also very interested in telecoms and progressing with surveying market. So now just giving a bit of an overview of one of the active case studies. So this is where the antenna is required. One of our earlier scopes, we had to do a trenching trial, and it was on an unpowered cable during installation. So the client here had the issue that they needed to do a multi-pass burial, and they were worried that on the second pass it would take it beyond the capabilities of the TSS 440. So as a benchmark trial, what they wanted to do before they had confidence in Artemis as a system, they wanted to benchmark against the TSS 350. So prior to the actual scope, there was a section of the cable laid and buried to 2 meters. Both the Artemis and TSS were mounted to an ROV, and multiple runs done with each. And the vehicle was flown at a stand up of 1.5 meters. So that was an overall range of 3.5 meters. And from the results, it gave the client confidence in the system that it could be comparable to technology they were used to, but could also go to that increased in order to use it for actual scope of work. As part of that survey as well, I haven't got the results shown there, but we also surveyed in-service telecoms cable with a 3-meter sensing range, and that was with the active system in this case. The key outcomes from this case study were that there was a new solution for tracking cables buried deeper than 1.2. The new solution for survey of cables buried greater than 1.3 post installation and when out of service. So again, when there's no way of applying a signal or there's no existing power. Having this increased range, as mentioned previously, allows you to fly the survey at a higher altitude, which means that you can fly at higher speed. So that was a successful trial in that case. Just one more case study on the active side, which was one of our key findings from some of the earlier trials. So in this case, this was an HVDC bundle, again, no power. One of the aspects we were wanting to look at here was the sensitivity of the system. So the cable itself was buried to 2 meters, and the vehicle was flown with offset of up to 3 meters. So what we did here, we did an initial survey run across the length of the cable, so following the direct cable path. So I'll just show, yeah, so the orange survey followed the cable path, and the cable was flying around 1 meter above the seabed. The yellow survey, what was done next was the vehicle itself was flown with offsets of 2.5 meters either side of the cable, so it's an exaggerated zigzag you can see there. And then the data was monitored throughout this. And what we found is there was minimal changes to the data itself. So we're trying to replicate how the data would react if the vehicle was being affected by cross currents. So we found there was minimal effect until we hit around about 3 meters offset from the cable itself. So this was a really beneficial trial to show that the improved sensitivity of the system and that it wasn't affected in that way. So there was almost no deterioration in the survey data, and that was flown when the vehicle was flown 4 meters above the product and 2.5 meters offset. So just note that it's only live active tracking and survey system capable of achieving this. So as a final, this is just a summary of the Artemis performance. So we have 23 operational projects we've done to date. Obviously, there's additional scopes that have been performed as well, but where clients own the equipment on top of that, but this is one we've particularly been involved with. So looking at the different areas here, we have tone cables, so that's on power or telecoms. We match the performance of the current best in class, so we are capable of doing the 10 meter detectability range, and the offset detection has been proven as well. There's operational improvements, so as mentioned previously, it can be mounted in a suite of ROVs, and we've also had it mounted just in lighter vehicles as well. We have done a trial with on the Seabed. The ROV pilot interface, we've had good feedback on that. It's simplistic, easy to use, so that's all good feedback on that side as well. And as mentioned, the common components across the range means that you can mount one system and utilize it across all of the different modes. So flag HV, AC, and unipolar DC cables, again, we've shown that improved performance, and that's up to a range of in the data shown previously, we've done it to with a 6 meter vertical offset, which one of the key aspects of this technology and one of the key drivers from the flags is showing that we have that ability to maintain production without interrupting any of the ongoing workflow. So as well, having that ability to have the confidence when rolling source is another key aspect with the live system. So coming on to the no power tone, so the active system here, we've set the performance benchmark, so 4 meters vertical, 2.5 meter offset, and the trial previously discussed. The operational improvements allow multi-path burial and tracking of cables up to 3 meters. And plus, we can go up to 5 meters. We have very strong signal strength in some of these cases as well, so which indicates that we could have went a bit deeper in certain cases. Having that ability to look at the live data, as mentioned, without the need for any external post-processing. And then just to finish up on the telecom side, the commercial status on this side. So our main focus was all around the power cables initially, but we're having a lot of interest from the fibre optic market from the telecom side of things. So as mentioned, with the passive system, that's fine. You can apply the tone and put that through into the. But when it comes to the when you need to use the active system, we're still in the process of proving that at the moment. So we have some additional jobs lined up this year, and so by the end of next year, we'll want to have that product ready and out into the market. So that is all from my side. But if anyone has any questions, let me know.
Thank you very much. Do we have a second microphone? Is it the only one we've got? Yes, that's the only one we've got. Okay, thank you very much. That's very good. Hang on. I've got one question maybe before I put it to the floor. Is this equipment that's available through hire companies, or is it directly through S&D? And the second question is, do you, if you are going to hire it out or sell it directly, do we have to use, as a subcontractor, do you have to use your technicians as well?
Okay, thank you. So yes, at the moment, the Autonomous Passive System is available to hire through both RTS and Seabed. With the active system, that is still direct to S&D at the moment. We do plan to roll that out, as we continue with the commercialization. So at the moment, the active system for use on ROVs and power cables is good to go. So hopefully we'll get that with the rental companies soon as well. But yes, so that'll be filtered in as well. So at the moment, it's just passive with them. Everything else comes direct through ourselves. You can both purchase or hire the systems as well. And in addition, for the offshore personnel part of the scope, we've had a lot of clients on the passive side just happy because that's a little bit more straightforward for the operation and said no, they're happy to run with the manual and to go ahead and use it. With the active, we would recommend having our personnel on board for say the first 1 to 2 weeks of the op, provide some on-board training to the guys, and then they can run with it from there themselves. So obviously we can also support if some people prefer to just have the S&D personnel on board throughout the op, but yes, So it's more about just the training side. Thank you.
Does anyone have any other questions at all? The temperature is climbing outside, and I believe it's 27 degrees, so I'm not going to keep you in here for too long before we have a break. I think on that note, I'll say thank you very much, Lindsay. That's lovely. Really good.
Thank you.
Practical information, it's just, there's going to be like a problem for what. There is an article for the, have a picture of some of the social media. They are here on, should not be able to, please give us notice and we'll take over. Just as you will.
Thank you. Okay, right. So next up, before we have a break, and I think it's definitely nice to get outside and enjoy some of the sun. I was hoping I could want to hold these two apart, but now if I can welcome Jan Erik to the floor to talk on behalf of Åkrehamn, and I presume what would be sort of competitive equipment to Attendees offices. So, thank you very much, Jan Erik, for being here today, and I'll pass you on.
Thank you. First, I have to thank Lindsay for having an excellent presentation and also going through all the applications. I think I can speed up a little bit. This is what I'm planning to talk about. It's I'm going to go through the steps towards making a system like Leslie have talked about, and how the system works, and examples of the projects and what we are doing at the moment for the developments. So, going back some years, we ABB, which is making nuclear power plants and locomotives, etc. They asked us if we could make a coin for them, and I said I was a bit puzzled because that's their business. And then we realized about the underwater coin, and then we were in business. So we made just a one-axis system. So we did a cable that was back in 2010, and the same year we made our first little ROV system, so we could follow cables, subsea. And then it continued. If you give somebody a system that can detect with one axis, they want 3 axes. And so the development continued. And in 2017, we made a system that could actually detect the cables X, Y, Z. Meyer is a German company, and they wanted us to screen all the technology, so we had to shake and bake. In the center picture there, so everything was taken to Nemco, so it was vibrated. We had thermal tests, drop tests, and so on the sensors. And we also had some work with the materials. We started with stainless steel, found out that wasn't good enough, so we went over to titanium, which is on the last picture here. So then Statnet came along, and we made smaller systems, and these small systems were quite interesting to make. We also made some tone generators, and we made also our first active system. And the development continued. So you see on the little picture there, you can see that we started with little one, and then we added some more functionality, roll and pitch sensors, and so on. And you see the standard Norwegian matchbox next to it. So we made it small. And then something interesting happened, because we got a visitor from a nearby company, And that was Kenneth, who's sitting here, he's one of the guilty ones, and saw the potential, so why don't you make a proper system with 6 sensors or 6 axes? But before that, we tested it. So we started with the tone generator. We did these cables you see on the picture. We sent the signals out to the beach, and we used this tiny sensor, which is in the gray part of, see if we get that laser. No. I need help here. I'm almost behind. There. At the bottom of the gray bit there. Yeah, I think it. Yeah. So we put the sensor in here in the survey pole. So and we positioned the cables at the beaches of Denmark. So that started off as a test with home generators. It was actually quite fun because we decided it was to send a 3 kilohertz signal or a 2 kilohertz. That's quite boring. So we sent Pink Floyd Dark Side of the Moon through the Skagerrak cable. Cannot be recommended for those of you who like music. It has horrible sound quality at the other end. So that's not the way to do it. But the system sort of worked. So this is now still in the history bit of it. And in 2019, I think that's correct, we started to make a complete system. We had background from the TSS 350 and the TSS system. And just to state that immediately, there's nothing wrong with the TSS 350 system, except for one thing, size and number of cables. So Kenneth, our ICA, saw the potential and entered into a cooperation agreement. Just get rid of that dot. So and provided financial and operational support to speed up the development. And these guys have used a lot of systems before, so they ended up giving us a sort of a sheet on the specification. It should have high quality and superior sensitivity. That is a quite big mouthful. It should have small dimension and be lightweight. It should be robust and be user-friendly. And I think you are taking that picture, Kenneth. So it's your picture. So we did a factory acceptance test. Yeah, built. We were very afraid of magnetic influences, so we worked under a power line, but on the outside place, and it worked fine. And we measured the sensitivity of the system, that it was no problem to reach 5 meters of burial depth or depth between the sensor and the cable. So now I will say 2 words about how the system works. And well, we have 2 small sensors. They are roughly this size, smaller than the microphone. And you have 3 coils inside, X, Y, Z. And they're made of titanium, 6,000 meter rated. So they have been through the shaking and baking tests at NEMCO. And these sensors also then measure, triangulate the position of the cable where the feed starts, same as TSS and Orion and all other systems. Really, it's nothing magic in that. And then we found out that it's okay to use more than 4 sensors. So we decided to use 4. So we are doing the same as a TSS 350, but we're doing it twice. And we can export the data in a TSS 350 format, so we get it up into Iowa or Quincy, and we have tried both of those. And then you have a fairly simple view. You see the positions of the front system in black there, and white is the rear system on a trencher. You see the history, like it was filed on most of these systems, but also the height in height. And you have to do the same thing. You have a green light for the subsea electronic model and sufficient signal. When we're talking about range of the systems, that is always fun. Because TSS have one number, I heard another number here, and the range of this system in passive mode, they all is dependent on the signal strength. We have the train to Bergen running in the hills behind the office, couple of kilometers. We can track that train. And I'm sure the TSS system can do it, I'm sure. So this number, what the maximum range is of this system, I think we should be careful sort of stating it that we are better or worse. We stated that we were better than TSS. Then we tried, we weren't. We were exactly as bad or as good. And there's also a difference here between detecting and positioning. We could detect that the train was leaving, but with a baseline of 2 meters, you cannot really position the train 2 kilometers away. So we just have to be a little bit modest in how we state this. This is not any criticism, but just an advice. This is the sheet I hate to show because it's changing all the time, but the detection rate here is more than 10 meters. I think we are pretty safe on that because we have tried 2 kilometers. Main comment is the 3-axis flux gate. Why flux gate and why not coils as the previous person of this yes? The reason for that is that you can make things smaller. And I found out that when I was repairing a TSS 350 system, and I was having my iPhone laying next to it, and I could detect the same on the iPhone as I did on the TSS 350. With other words, something had happened between 1970, when Steve Coles made the 350 system, and today, sensors have become smaller. So we started with that, and then we crashed the Mavic Pro. That was interesting. We found that in there, they are really good small sensors. And in the end, we found that the Navy are using very good magnetic sensors in mines. And then we decided to go for a flux gate. So that's the history there. Examples of completed projects. Yeah. This is Kenneth's, and we heard about comparative testing or baseline testing, and this is definitely an example of that, because here you have an early Orion system in the front there, and we are inside here. And I'll just play this little video, see if it works. Yes, it does. So we know what they're doing. And the little dotted green line, that is the positioning from our bank track system. And yeah, so this is a playback, obviously, but it's a nice presentation of how these systems works. Speed of survey really depends on how many hits per meter you want to have on a pipeline. If you're running your pipeline at 1 meter per second and you're sampling at 5 hertz, you get 5 hits per meter. And if the bending radius of this cable is 25 meters, that's obviously enough. So that is really something you can agree with your customer. It shouldn't be a problem, or you can speed up the system and have 100 hertz if you want to do that. So this is, yeah, I think it stops now automatically. Thank you. And then we take the next project. So then we got connected, we got contacted by a company in Sweden, Baltic Offshore, and they had got a contract with Global Connect, and they had the installation of 4,000 kilometers of fiber optic cables, and they all had to be dug up, and they were using this Raptor from the Indian Ocean just off the coast there. They're making that little trenches. So we put on 4 micro sensors. You can see easily where they are, because what isn't professional, like they put on the sensor behind it, same position. So they use that, put on the bottle. You can see the bottle on the Subsea electronics module is at the ready bottom now. And the sensors are here. These sensors can be mounted sideways or flat. But you just have to turn the inside so they take in all directions. So that was that project. So then we had 4,000 kilometers of fiber optic cable, and then we went back to a field in Norway in Germany, and that was a totally new application for us. So using 2 MagTrax sensors up here and 2 down here. And that was Reach that did the job. The only thing we did was to help them with getting the cable length and protection of the kit. And the customer was pleased and sent me a nice email or SMS. For the Norwegians, I translated it, and he said, you know, the micro system worked fine, and the accuracy was around 7 centimeters. How the hell do he know that it is 7 centimeter accuracy? What is the reference system? So pitch of salt is always good, but he believes it is 7 centimeters, and then it is 7 centimeters. That's important, because I think that is so good that he sort of believes that it is 7 centimeters. Okay. Further developments. Now we're approaching the end. Yes, further developments. I have background from research. I've been working as a scientist at the Trondheim University for many years. I don't stop. I'm actually a pensioner, but I still don't stop. I still go to work every day. I'm the first and the last one that leaves, so that is some of the problem. So now we are talking about more sensors. This is not to sell more kit, because it gives you more headache, but the idea is if you are having more sensors, you can get rid of the Earth's magnetic field. With other words, you can subtract the magnetic field of the Earth, and you can subtract the magnetic field of the ROV, because the ROV is a big source for disturbance. And as you all know, survey is about signal to noise ratio. Doesn't help if you put on a lot of signal if you have a lot of noise. Doesn't get better data pool. So last week we went to a secret company in Bergen that has made a fantastic new ROV. And we tested this theory, and it was quite fun because we could detect cables with and without current. With other words, the steel in the cable or the iron in the cable. We could and we also had a magnetizing kit along, so we could also check if you could follow magnetized cables, and that is fully possible. So with other words, dead sea cables, also without any current in them, can be detected if you are using the available technology. And I think Knut Kleppe here is probably pretty proud of the results that we got, without mentioning the name of the company. Okay. This equipment is used in the survey business. In the survey business, they have a task. You're supposed to produce a survey. The customer wants very often to have a 3D model of a cable or a pipe laying down in the mud. And normally that is a hell of a lot of work. And still it's a little bit of work, we can tell you, especially processing. But in this case, we put on 2 magnetic sensors, and we had 6 Innomar sensors. And the Innomar sensors works then as a penetrating, multi-beam penetrating echo sounder. So you get you use the phase difference between all these antennas, and then you can process out all the particles down to around 10 meters, which we did on this job. And this is fun because now you can sort of go down a track and you can do a survey in one line and you're finished. Well, if they believe you. So here we have this 3D model, and of course we have to do it 3 times because the end customer would like to see that we actually follow the same cable each time. You see the 3 passes, the red, green, and blue. And if you see the coordinates, it's outside Rostock, Warnemünde, where we have done a lot of research together with Innomar, which is now a Nortec company. That's cool. For those of you who didn't know that. And the result looked roughly like this. You sort of we did 70 meters, 10 meter penetration, and roughly 365 meters. And this was the cable we just found from a windmill outside the windmill, from a small boat. And we used the magnet for steering the boat manually, no automatics. So we had a really good guy sitting there steering the boat with the screen showing him which direction to follow the cable. It was a 50 hertz cable. And now back to range. In the marina we started, it is a tunnel for cars. And the first thing we got was the lighting system in the cable in the tunnel, so we could track the light in the tunnel, and the tunnel was 20 meters below the seabed, and it was roughly 30, 40 meters deep. So, but once again, this has to do with the amount of current flowing in that cable. Okay. So, we are a tiny company placed in Åkrehamn. So if you are in Oslo visiting relatives or are from Oslo, please come and visit us because we are there. We always take time if somebody bothers to see us. And I think we normally, since we have been in the business for quite a while, personally I've been in this business for 40 years, which I think is a long time. So I state that we understand the project because we have done it either as client or as partnership or whatever, or operator. And we can support you in not a local dialect, but in a lot of languages. And so I speak these languages myself. That's me. So next time we will demonstrate the kit is now at Hydro in November, but we will also be at the wind energy in Hamburg later this month, together with a German company called Menger, who are quite keen in selling our kit. I think that was roughly what I had.
Very much. I know it's always a pleasure to see you next time. If you could reply to that emails, let us know.
Yeah.
So, will you be writing 7 centimeters on any of your data sheets, or will you?
No, I don't. I personally don't like to do it because it depends on so much. And as I said, it's signal to noise ratio. But the physics is the same for all the 3 mentioned systems today. And so it boils down to processing and how well you are sampling your data, how fast you are doing it, and so on. So I don't think there will be any differences in flight height or in speed or anything. All these systems can do this. I think the advantage of this system to do the commercial pitch is that our sensors are stronger.
Well, regardless, 7 centimeters is what everyone's going to remember here tonight. Does anyone have any questions at all for Johan before we take a walk break and go and enjoy the sun?
You can also attack me outside, that's fine.
It's very easy to spot. I think that will wind up. I think I don't know what it's called. Take a quick half-hour break and go and get some food and drink and enjoy the sun.
Okay.
Hello?
Hello everyone. Can we have the rest of the noise people please sitting? Okay, I think we'll crack on. Those people at the back can turn the volume down a bit. We can continue our conversations later. Just a quick update because Runa from Deep Sea, who was planning to be here for the first introduction keynote speech, unfortunately he's not going to be here at all now today. So I would highly recommend everyone making their way to Bergen on the 17th of October to listen to him. So. On that note, we'll then move on, so if everyone could just pipe down a bit, please. Get some silence. Good, I'd like to welcome Nagasha. Not quite sure what that was for, but excellent.
I appreciate it.
You don't need to do your presentation now.
Yeah.
So, welcome Nagasha from Ava, who's going to talk about that, and I'll hand this call to him.
Thank you. Nice to see you all, and happy to be here for my first SID here, and happy to give you a presentation of one of our newer technologies, which we have made together with Voice, and that is the Voice vSLAM powered by IVA Navisuit, which is a technology that makes it easier for the users to more easily create real-time 3D point clouds in order to get full coverage, and also to make photogrammetry workflow more easy. And I'm not only going to talk about how the solution impacts the inspection results, but also how it can be used as a piloting tool. So let me quickly introduce myself. My name is Legishan. I work as area sales manager at IVA, where I'm helping and supporting clients in Scandinavia. And I'm also accompanied by my colleague Mike Gallo, who is our business development manager within Subsea Robotics and AI. And a little bit about IVA. We are a company based in Denmark. We are approximately 120, 130 people by now. And we offer subsea software for subsea surveys, as well as hardware solutions that would be ROTV solutions. So basically sensor platforms, turnout sensor platforms, which could be our Scanfish or Viperfish. And we are in a part of the Covelia group, which I think many of you are familiar with. So in the same group as Chelsea Technologies, that does environmental monitoring sensors, Wavefront, makers of sonars, Sonarline, of course, specialists within acoustic, optical, sonar technologies, and then we have 4Cs as well, part of the group that would respond to defense inquiries, so they would actually be making a package solution based on the technology from one or multiple of the companies and offer it to our defense clients. And in the end, of course, we have Voice, who is our partner in this whole collaboration, who does optical sensors such as laser scanners, cameras, and lighting solutions. And given that we are all in this group together, gives us all the elements required for subsea development. And we can do basically almost everything except the vehicles itself. And as mentioned, voice does laser scanners, cameras, and lighting solutions. And for this technology, we will be focusing more on the cameras, more specifically the discovery vision systems. And on this one, we have two different cameras. We have the mono camera, a single camera with a bottle. And to the right here, we have the Discovery stereo camera. And while these cameras are different, they still share some system architecture and specs. So they both come with the global shutter, ensuring these very nice and crisp images, which I will show you some examples of later. Synchronized LEDs that can be exposed for a very short period of time, down to milliseconds. Of course, they could also be exposed continuously, but that would have an impact on power consumption. But this is of course very important because when we do subsea surveys, the only lighting we can rely on is the sunlight. So this is very essential for subsea imaging. It can gather up to 30 frames per second, and once that come in, it will be processed in real time, so it will be undistorted, colorized, levelized as well. Possibility for multicast IP video stream, so you can stream from multiple sources, and both also come with high fidelity 3D models. And for the VSLAM technology, it would be the Discovery stereo camera that is being used because compared to the mono camera, this camera provides more true to size imaging. So far this is the camera that is being used for VSLAM. And to jump to some examples here, on the left you can see the visuals from a basic ROV video. So this would be rolling shutter. So when you are in movement, that would cause some blurry images. Low dynamic range as well. You can see in the foreground the light is really blown up on the cable, on the chain, sorry, where there's a lack of detail. You can also, it's also difficult to see what's actually going on in the background as well. And when you do point clouds, you of course need to have as many pixels as possible, which is very difficult to obtain from the first example on the left, if that is even possible. So if we go to the Discovery video example, yeah, the result actually speaks for itself. Global shutter, so we get this very nice and crisp picture, high level of detail on the chain itself, and in the background as well. You can even see the patterns on the bottom in the background. And also the dynamic range really comes into play, where it gives just a perfect lighting, ensuring that we get all the details. And this is an example of the Discovery 3D result. So a little bit about this system. The LED lights comes with a capacitor inside them. So there are no additional bottles or anything, and they are plugged directly into the stereo camera. And then the stereo camera itself is plugged directly into the vehicle. So in this example, we see a work-class ROV. And it's usually operated with a range of 0.5 meters to 5 meters. And the stereo system comes with either 300 meter or 4,000 meter depth rating. And as you can see, two cameras, each with 8 megapixels. And you can also see that the viewports are dome-shaped. And what Voice has done is they have actually mechanically resolved the index of refraction of the water. So there's no calibration needed afterwards. If they were flat viewports, the index of refraction of the water would distort the images differently. So, and that would be whether you are operating in salt water, fresh water, on the surface, or at deeper depths. So that would actually require some processing power afterwards as well. So having these dome-shaped viewports would save a lot of processing power and time afterwards, and that's why they have chosen this, this solution. And as you can see, there really isn't a preference on what type of ROVs Voice would like to integrate the system on. Actually, their ability to be versatile and integrate is tremendous. And yeah, some examples on what kind of ROVs they're able to integrate on. It really comes down to customer's application and yeah, the vehicle they have. So what's actually going on inside the camera? And everything that's happening here is basically real time. So what happens is that we get these 30 frames per second, which are then in real time being processed, where the images are being undistorted, levelized, and colorized. These stills are then encoded to video, which are then streamed to the top side, and it has a latency of 150 milliseconds, which means that you can actually use this video feed for piloting. It's not the main purpose of it, but of course it's a very nice side benefit. Once the stills are being processed, we will stream 10 frames per second to the top side, and these are actually the ones that are being used in the IVMX Suite VSLAN to create the real-time 3D point clouds. And of course, when you do the final end deliverable to customers, we recommend to use an off-the-shelf photogrammetry software. So in this case, we have used these two. And basically, that is the whole workflow. It's happening in real time. So coming to some examples here. So here we see the vehicle is pointing towards the cable, and simultaneously we are creating the point clouds here. And the whole purpose of having this technology is to make sure that you get full coverage the first time you are out doing the inspection. So if you don't get coverage, you can easily see it by, visually see it by there's patches or black holes, and you can easily detect that and go back to that point and do a resurvey instead of going back onshore, finding out, and then go back again. So it's a very nice tool to get full coverage the first time. Also, tracking is very important. So if the vehicle suddenly points away from the structure and out to the openness of the seat, the software will actually tell you that, hey, you have lost tracking. You can go back to the last point where you had very good tracking. So it gives you that option as well, and thereby it can also be used as a nice piloting tool. And here are some quick examples from the VSLAN technology. This is a customer who used VSLAN for the first time, who sent us these images. So here we see a subsea spool, 30 meters long, and really you can see the level of detail on this. And like the end deliverable would be something like this video. Again, high level of detail, and you can also see a scale bar there, which is placed by the customer. This is not needed in order to create the video, but it was more for the customer to validate the accuracy themselves. But otherwise, this is what an end deliverable would look like. Very high level of detail. Another example from an asset in Brazil, and again, result speaks for itself. You can really see the dynamic range coming into play, the high level of detail. You can see what's in behind as well, and the lighting is just perfectly. Nothing is blown up, and this is not necessarily something that you would be able to acquire with a regular ROV camera. Another example from a plane wreck, sorry. Again, high level of detail. You're able to see the scratch marks, the coloring in the front and on the outside, but also see what kind of objects are inside as well. And some nice examples from the Titanic. It really just shows you the importance of building your device from the ground for 3D modeling. So, as mentioned before, the software, the technology can also be used as a piloting tool. So, if you have other data sources on your vehicle, it can be displayed in the same software as well. So, there's no need to learn a different software or use a different device to get the data inputs. You can actually get that in the same view, so you get the video feed, the 3D point cloud that is being created, and then also the data source that is incoming. And of course, if you have multiple data sources, we can also create additional views as well. So you get everything in one package, if you can say so, making things a lot more easily and more convenient. Another example here, one of the things we can use the VSLAM technology for is also change detection. So this is an example where we have made a survey of a cable. You can see a blue one and a yellow one, but these are actually the same cable. The blue one is the first scan we made, and then after some time we did a second scan. And those two scans we are able to put together, and when you overlay them, you can visually see that there has been a detection. It might not be something that you would maybe realize when just doing a second survey if you haven't looked at the first one, but you're actually able to put them together and actually visually see a change detection, and not just visually you can see it, but you can also use measuring tools in the software to see how much it has actually changed. So an inspection manager could look at it and say, okay, the cable has moved around half a meter. Is it critical? Do we need to act on it, or is it perfectly fine? So it can also be used for change detection. Another nice feature is the ability to simulate. So as mentioned before, we did 2 scans. So if you have done 1 scan, you would have this 3D model here, and then before you go out and do the second scan, you can actually simulate the second scan at first. So you would take a look at the first scan and make your own run line, the way you believe would give you most coverage, and then you can simulate it. And if you see that the coverage isn't quite there yet, you can always alternate your run line. And that basically makes it much easier for customers to make surveys, because they know exactly where to be, the exact height, the exact run line, making sort of a mission planning, a very good mission planning beforehand, and thereby also using less time on the inspection, the second inspection. So to sum up, really, enhanced inspection, quantifiably measure objects in 3D, so you don't really have to rely on subjective assessments from 2D videos or images. You have increased coverage, you have the chance to actually get full coverage because you are able to see what you have covered in real time, and the software is able to also help you get the best tracking as well in order to get the best results. It's ready to go, no precision, no calibration needed. The voice camera is already calibrated in factory, so there's no further calibration needed as well when customers or users need to use it. As mentioned before, change detection, you can compare data sets with each other and see visually if there are any changes. And also contactless metrology for detailed scope, that could be change inspections or spool metrology, which could be for longer measurements. And for piloting, again, you know what you've covered, which is of course very nice to know before going back onshore. Improved flight planning, so you can avoid any rework going back to the site. Increased spatial awareness when navigating these complex structures, so you know how much room you have around you. Easily create and store 3D maps for mission planning. That's like the example I mentioned earlier, where you can use that for simulation. And then of course accurate visual range positioning output, for example, seeing the run line of an ROV, making sure you know where you have already been. And if you'd like to know more about the Discovery camera and the system, whether it's for purchase or for hire, you can contact Luke, who's the Vice President for Sales and Marketing at Voice. And of course, if you're interested in of course, specific projects, mission planning, subsea robotics, autonomy, or in general, IVA sales, you are more than welcome to contact me with my contact info here. So that's it for me. Thank you for your attention.
Thank you very much. That was very interesting. Just goes to show what graphics can do for a presentation. Very aesthetically pleasing to watch. Does anybody have any questions before I launch it tomorrow? Oh, okay. Hang on a minute. I've got it right. Can you shout?
What kind of processing power do you have subsea and topside in order to be able to use this?
So, yeah, so the cameras have a Jetson card inside that does all the processing on board. That's mainly, like we said, so just to get the to fix the raw images basically and do the polarization on board. Then those images get streamed topside, and it's topside that we consume the images to do the VSLAM, for now at least. And yeah, in terms of what you need topside, I mean, if you go actually on the download.iva.com, I think that's the website, there's a download site for IVA. When you click on VSLAM, you can see what the recommended specs are. But in general, good processor and a dedicated discrete NVIDIA GPU. Yeah, it's a good PC, a good RAM as well to use VSLAM in real time.
Okay. Metrologies and core visibility, please discuss.
Metrology, thank you. You have half an hour. So, well, it depends. In terms of visibility, always comes up obviously when we present this product, where's the visibility. There's a couple of things that we also showed during the presentation. The cameras, the lenses themselves are much better than your general ROV camera, so you'll get much better results than your ROV cameras. And then, yeah, in terms of like the distance, what distance, okay, the minimum distance that you normally take is like 0.5 meter, but you can take it even closer if what you're looking at is, for example, a chain link. A chain link you can get very, very close as possible by the ROV, and you should be able to get results because the chain link gets reconstructed in a matter of seconds. Now, if we're talking about more ambitious metrology, like spool metrology, improved vis is still achievable. It's going to be a bit of a task, but then again, what is your alternative? Is it LiDAR? LiDAR is going to have the same struggle. So what will happen if you are in vis and you're trying to do spool metrology? It's just going to take longer. It's going to be patient, and you need to make sure that you keep in tracking. And probably, but the good thing is that the system on the fly will tell you if you have tracking, if you're doing the point cloud, so you'll be able to find the right setup for the situation you're in.
Okay, and you've still got LVL there, so you can use that.
Yeah, well, depends the type of metrology you need to do. It depends. Obviously, this is not a one size fits all. It really depends on the type of scope, and there's different options out there to do metrology. Absolutely.
Good. Okay, thank you very much. Any other questions at all? I think the board is rolling as well. Okay, I can see everyone wants to get back outside. Thank you. Thank you very much. Okay, just going to welcome to the stage Andy Spurden from Aquatech UK. Who's going to talk about another subject matter.
Can you hear me? Yep. Right, good afternoon everyone. My name's Andy Snowden from Aquatech. I'm going to give you a very quick overview of subsea pipeline integrity monitoring technologies. So a range of different technologies that you can use on subsea pipelines from near the seabed. And really this is, as a starter, what are some of the integrity challenges that people might face? What are the sources of subsea infrastructure performance uncertainty? So for new installations, for example, where you may not have complete metocean data, you may have inaccuracies in your thermal or flow modeling. And of course, you never know exactly what's going to be flowing in those pipelines. It's going to vary over time. You might have Joule-Thomson cooling or other cooling effects on the pipeline. And then with legacy systems, those problems only get worse. The temperature declines, the pressure might decline, and of course the composition changes again. And if you're developing in brownfields, you may even be putting something completely different through those pipelines. If you're putting in new infrastructure, you may also discover leaks and seeps. So there's a number of issues that you might want to monitor. And all of these different uncertainties, whether it's VIV, flow-induced vibration, pipeline walking, buckling, leaks, thermal stress, all things that are of concern to pipeline operators. So what I'm going to do today is just talk a little bit about, I'll introduce who Aquatech are. I'm going to talk about some communication technologies that we use, which are key to getting the data from the pipeline back to the user, and then run through some measurement technologies. So there's a lot of things on here, and I'm just going to touch on each of them very briefly. So we're based in the UK. We've been delivering subsea, award-winning subsea instrumentation since 1990. And the key to it is smart devices that monitor the health of your subsea assets. So within Subsea Integrity, we're taking measurements, we're communicating that data, we interpret it, and in some cases we control other processes with it, and I do have an example of that. We have a couple other divisions as well. We have a sediment monitoring division and a division that monitors the marine soundscape and looks in particular at the effects of man's interaction with marine mammals. But within Subsea Integrity in oil and gas, this is the world that we're involved in, taking measurements from the surface right down to the seabed, and with a range of support instruments, whether it's modems, distributed measurement systems, dials and gauges, data logging, and about half of what we do is some form of custom development. And that all translates across into offshore wind as well. So I'm going to start by talking about, if I can make this go away, here we go, communications technologies. If you like a sort of underwater Internet of Things, the concept of having lots of devices scattered around that deliver small packets of information back to a data hub. So when you have a number of measurements that you want to take in a given subsea locale, it could be pipeline pressures, it could be met-ocean data, it could be information on your cables or cathodic protection. It's often really difficult to get that data back into one place, and cabling is generally impractical. And so we've developed a very simple communication system that simply takes readings and sends them out into the water and then forgets them. It doesn't need to be interrogated, it doesn't need to stay powered up. Much like Internet of Things, it just takes a reading and sends it. So this is one example. That device there is about the size of one of the small cans that some of you are drinking. It's pretty compact. This particular device is used for monitoring pressure. It's got an acoustic transducer in it. There's electronics in there for acquiring data from a transducer and transmitting it. There's a battery pack in there, and that battery can typically, on this device, which might transmit a pressure every 5 to 10 minutes, that would keep it going for maybe 4 years. And then at the end, because it's a pressure sensor, it's got a mechanical pressure coupling to a pressure sensor. And going along with that, you then have, not to scale, some kind of acoustic receiver and some software that will be used to interpret that data for your particular application. So how do we get that data back to the user? Well, that particular system was originally developed for monitoring the hoses used in offloading buoys. So you have hoses here, multi-section hoses, that are actually coming up to the surface to a calm buoy. And each one of those hoses has a pressurized and an unpressurized carcass, and these pressure sensors measure the sensor within the carcass. But the key thing is that there's lots of them separated about. You couldn't cable all of those readings together, and instead they're transmitting the data into the water. And usually operations like this have a standby vessel, and so they can just lower a receiver into the water and pick up the data. But equally, you could fit your receiver onto the calm buoy itself. Or if you think about other applications on a jacket, you could, or an offshore wind farm or whatever, you could have permanently installed receivers that are gathering all of that data together. But you could also mount it on an ROV, or if you have in-field ASVs or AUVs, then they can also be picking up that data as they fly by. And then what do we do with that data? Well, you can, once you have the sensing there, we can add data logging, and we can also provide some edge processing. So it doesn't have to be simple slow changing signals like pressures and temperatures. It could be a faster signal like vibration, motion, etc., which I'll talk about a little bit later. And with that edge processing, what we do is then condense it down into the things that you really need to give you peace of mind. So that is a status signal. Is my kit working as I expect it to? Is it performing within limits? What are the statistics for today or for this hour? And then you just transmit those very concise updates through the water. Provide an operator dashboard that will display that in whatever form is useful for your system. And if you find that there's a problem, that's when you can then start to intervene, maybe on your next inspection campaign, and download your data optically. So this is the second of our communications technologies used for real-time data transfer. Here you see one of our instruments downloading data via an ROV back to the user at the surface. And these instruments provide a seamless interface between the subsea instrument and the surface. So this is when you want to get your forensics, your data time series over maybe many months or even years downloaded quickly. It comes in a deep water housing, but also a lightweight one that you can put on the small list of micro ROVs if the weather conditions, the met-ocean conditions would allow. So that's a start on technologies for communication, and I want to skim through a few of our measurement technologies. So in terms of pipeline integrity monitoring, there are a few different things that are useful. Cathodic protection and monitoring, looking at attitude, vibration, motion, temperature, and strain, for example. And all of these technologies are technologies that you would mount on the pipeline. They're not things that you can guess from flying over. They're not things that you can work out visually. So they need some form of physical contact with the pipeline. Coupled with that, on an ROV, we have leak detection and localization using ROV-mounted sensors, and of course the communications technologies to communicate with all of the other instruments that are on the pipeline. So a few slides on each of these, just to give you a very quick overview. Lots more information than I could probably take in all at once, but I've got a booth over at the back and happy to talk about them in more detail later. But let's start with cathodic protection and monitoring. So many of you will be familiar with CP surveys where you go in and you do stabs with an ROV and you take a potential, often a single potential with a silver chloride cell and a stab probe that goes onto a bit of exposed metal, maybe often an anode. Not the ideal place to take the potential. You really want to look at the steel of the pipeline that's protected. What we do is we add a second electrode that gives you the peace of mind that your electrodes are calibrated together. And we then take measurements at a single point. And what that does, if you look at a time series of stab protection potentials, they often vary massively from one year to the next because they're not in the same place, they're done in a different season, a different state of the tide. So fixed monitoring with an instrument here that is rather like that pressure sensor I showed earlier, gives you that very stable time series. Once again, it has an acoustic transducer and the data acquisition and transmission electronics. A battery that for cathodic protection could be running for up to 15 years. It's a slow changing process, and once an hour it'll run for 15 years on that sort of battery. And at the bottom you see those two sensors. There's a zinc electrode and a silver chloride cell. And you can mount these either with one of these pipeline mounts, these clamp on. Just below here is a magnetically attached sensor. So this type of sensor is good for attaching to structures, the top one. At the bottom, I have an example of an attachment to a hull. And in this case, although this is not pipeline, it does interact with the seabed. This is an FPU in the Norwegian North Sea. It's the Boulder FPU. As you can see, the risers and moorings, there's some remote wellheads, and the operator needed a life extension of 15 years. So we've been working with Boulder since the late 90s when we first did some CP monitoring on it. And we recently did some work on this particular upgrade. And the solution was to add in an impressed current skid with an impressed current power supply mounted on the vessel, a new dynamic riser that was provided by others, the subsea junction box, subsea distribution unit, that's splitting out the power cable to the impressed current skid, and also an umbilical to the remote wellheads. And what we also have mounted on the vessel is that device that I just showed that's magnetically attached to the hull, and we have a few of those attached to the hulls at different points, and they're measuring the cathodic protection pulse potential and transmitting that through the water. So what that does, you're monitoring your potential just as you might on a pipeline. You're sending that into the water, and you're then able to use that potential to control the impressed current and have a closed loop control. So this is roughly what it looks like. We're monitoring from the hull, we're sending that data, and in fact our receiver is down here on the seabed. The data goes back up to the vessel, to the power supply, which is then controlled and adjusts its current to deliver the right current to the impressed current sled to provide the cathodic protection that is just right for that vessel. It's not under-protecting it, it's not over-protecting it. So that's a very quick example of cathodic protection monitoring and cathodic protection as well. I'll move on to attitude, vibration and motion. Monitoring pipelines for example, VIV, motion, flow-induced vibration, etc. So we developed a number of different technologies for doing this, using accelerometers, gyros, self-contained monitoring systems. The device on the top right was used for vortex-induced vibration and was coupled to, in fact, a Nortec vector sensor done a few years ago now, so that we were looking at both currents and vibrations at the same time. At the bottom, a wind farm application, which I'll bring up in just a moment. And then here, using another of our acoustic comms technologies, is a system that's designed to look at and be triggered by events such as pipe walking, buckling events, etc. So with that, we have devices that are mounted on the pipeline at periodic intervals. They're monitoring the acceleration, the attitude of that pipeline. So periodically they will transmit, each one of them will transmit a signal and will daisy chain them down the pipeline. And then if an event takes place that exceeds a certain motion or exceeds a certain change in attitude, then that will be triggered on demand, and we'll also send that data down the pipeline. An example with wind farm, this is Barrow Wind Farm in the UK, and the particular application here had some issues with installation, and there was scour around the cable protection system. So we installed 3 accelerometers on there, coupled with another Nortec system. Shout out for Nortec again, this is an acoustic wave and current meter. So again, we're monitoring both cable motion and the forcing function, and providing all of that information in one place, so that you can determine whether the cable and the cable protection system are performing to specification. Moving on to pipeline temperature monitoring, assuring flow integrity. We were approached with a particular challenge that was a transnational gas pipeline in around about 2,000 metres of water coming up a continental shelf to the surface. So as it rises up the continental shelf, you get product cooling, cooling to sub-zero temperatures. There's a gas pipeline. And the operator was finding that the temperatures at the receiving terminal were lower than expected, and that prompted concerns about whether they could maximize their flow because of the risk of things going out of limits on the operating temperatures and potentially introducing thermal stress. So in order to get a better understanding of the pipeline thermal characteristics, they wanted to take actual measurements of that during operations, during different flow conditions, and indeed different metocean conditions as well. That poses a number of engineering challenges. First of all, this was an existing pipeline. It had to be non-intrusive measurements, so this is an example of something that we've done before where we've had a thermal well installed, but it's intrusive and we don't have the opportunity to do that. It had to be retrofit by ROV, so getting a guy on deck or even a diver to go down isn't going to happen. So that approach didn't work. It's a coated pipeline, no damage to the coating required, so we couldn't get direct contact with the metal. And it also is an H2S environment, so needing resistant materials. The expected deployment life was over 5 years, so we needed to size a battery that would suit that. And they wanted to get all of their data back on their twice-yearly inspection campaigns. And the important thing was that they want the internal product temperature. And that turns out to be the biggest challenge of all, because we've worked with, in fact, the systems that you see there, monitoring skin temperature. And skin temperature is one thing, but actually deriving internal product temperature from that turns out to be quite challenging. So this is the device that was developed, our Pipe Guardian system. It's fairly small, the same sort of concept of an instrument with a battery, with acoustic transducer, optical communications, and a plastic saddle that mounts onto the pipeline, so a contoured saddle. And if we look underneath that, we can see there's 4 magnets there, providing around about 100 kilos of attachment force. Standoff foot so that you can initially put it on the pipeline without it snatching on, and then you wind that standoff foot out. In the middle is a temperature sensor, and around the edge is a gasket that traps the water in there a bit like a wetsuit, so that the water inside and under that saddle is a constant temperature. And then we also measure the environment temperature as well. And to get from that state to getting the actual product temperature was through a combination of both modelling, CFD modelling, and also practical experimentation. So we took the pipe section, we filled it with different products, we ran it from plus 20 down to minus 15 degrees with all kinds of different conditions to confirm the thermal modelling. So here you see it getting ready for deployment in the basket, being brought up to the pipeline, and then here being installed, and that magnetic or that standoff being wound out so that the saddle finally sits down onto the pipe and makes contact. And some initial results from that. This was just when the instrument was put in. So we see at the start the temperature is fairly high. It then comes to a peak as it's brought out on deck. Then it's lowered into the water. The sensor on the pipe has a slower time response, and so you can see that it is sinking down rather more slowly. That's the blue one, that's the pipe sensor. And then at the point where it actually makes contact with the pipe, then you can see that the pipeline sensor drops down another 4 or 5 degrees, and that's where you see the cooling effect of the gas inside. So around about 4 hours after deployment, it's stable. And what we're able to do with these readings, together with the modelling, is we have a relationship that gives you the internal product temperature accurate to within about a degree. Moving on to another technology, Connectron, our retrofit strain monitoring technology. Something that came initially from a requirement from a North Sea operator for an ageing platform. As you can see from that picture, it's quite low structural redundancy. There's not very many braces. They're big braces, but if one of them starts to suffer fatigue and get damaged, then that has severe implications for that platform. And this particular platform had been downmanned a few times in recent years because of those concerns. So the operator was keen to find a way of improving and ground truthing their model. And they wanted to measure the strain, the actual strain on structural members, and to match that with the model. So it needed to be ROV retrofit, not diver. It needed to withstand 100-year hydrodynamic maxima. The device that you see here is designed for a 1.2 meter diameter pipeline, so that gives you an idea of scale. Attached with both fixed and movable magnets adjusted by ROV, and giving a total of 1.3 tons of attachment force. It's at minus 43 meters, so the hydrodynamic forces there are still quite significant. And then it has 3 sets of strain transfer mechanism, one at 12 o'clock, one at 3 o'clock, and one at 6 o'clock on that pipeline. And together, those provide you with enough information to get axial load and bending moment. So this was installed during just after sort of COVID time. We provided live virtual support. So we were able to watch this video feed from the installation vessel from our offices. And you can see it there being placed against the structural member, which has been cleaned. It has to be cleaned, but it doesn't have to have any other surface prep on it. You can see it's also sitting between 2 bracelet anodes, and that's part of the reason for the narrow shape of it. And then we downloaded data using the optical comms. So this video has popped up before, but to put it into context, the instrument there is being set up via the optical communication link. That data is going up to the ROV operator cabin, where there's a PC that's connected to the vessel network, linked via satellite to our offices 1,000 miles away. So we were able to communicate with that device remotely over that distance and set everything up while watching the videos coming in. So it was a good test of whether you really need to send people offshore or not, and necessity meant that we had to do it that way. As far as the data is concerned, we got, this is a set after 3 months, a complete strain data set from all 3 quadrants. So here you see a time series with frequency on the y-axis, time on the x-axis, so that's 3 months time series. You can see a couple of, so the lines there are 2 structural resonances, and then the red is the wave-driven action of strains at lower frequencies. That's the big signals, but if you now look at a quiet period, this is 1 minute of strains on all 3 quadrants, so they're superimposed. And to get an idea of scale, this is roughly plus or minus 20 microstrains. So just a few microns of movement, you can see the kind of resolution that we're getting there. Okay, last technology, leak detection and localization. This is an ROV-based instrumentation suite. So all of the others would be pipeline-based with some form of acoustic and or optical link to communicate back to your pipeline, back to your ROV. This system comprises 3 sensors. So we have a data acquisition unit that sits on the ROV, communicates with the surface, and then a choice of 3 different sensors. The acoustic one is able to listen to the high frequency sound of an acoustic leak, and it will detect that over ROV noise and other background noise. And we have a fluorescent sensor that's used for detecting dyes that are typically injected during hydrotest and also in closed systems. And finally, a thermal sensor that you can use to fly over a leaking hot product. So I know I'm running short of time here, so briefly to summarise, CP monitoring, attitude, vibration and motion. Oh, that's gone wrong. How do I go back? That's lucky. Strain monitoring, temperature monitoring, and leak detection and localization, a whole range of different technologies, but all designed to give you peace of mind that your pipeline systems are all in good working order. Thank you very much.
Thank you very much, Andy. That was very interesting. Very highbrow, a lot over my head. So I'm hoping someone's got some questions here for Andy before we maybe will, well, no, maybe we will take another break now. Oh, you're way too far away. Just shout, please.
For the acoustic communication and for the optical one, what is the data rate you manage to reach and how you deal with some fluidity for optics or like vessel engines for the acoustics?
So for the
Can you just repeat what he says so that everyone can hear it?
okay, yes. So for the if I understand the question correctly, you're asking about the data rates for acoustic and optical, how we can work over the noise of the engines for the acoustic, and how we deal with turbidity or sediment in the water for the optical. So 3 questions there, but so let's start with the optical, a range of between 100 kilobaud and 1 megabit per second. Aim to work over short range, so this is an ROV carried system, and if you can see it with the camera, you can use the optical communication. So it will work through turbid conditions. It's not a very long range system. For the acoustics, data rates are very slow because we're sending very small packets of information. So it's not so much the data rate as the update rate, which is typically once an hour or once every 10 minutes. And the systems have enough filtering and digital signal processing to deal with the ROV noise, and they can also transmit to the surface as well.
Thank you. Okay, if there's no other questions, we can take any other questions quickly? Oh, okay, we can take another half-hour break, go outside, enjoy the sun again, and we'll meet back at 3:30. Yes, 3:30. Thank you.
Thank you. Currently, whole range.
Thank you very much. It's a bit more attentive this time than last. We're learning. Another hour, and then we'll call it quits. So we've got this one wonderful presentation from Gauthier, talking about USBL, as I thought it was. But
it's part of the presentation.
And then we'll have Ayla talking and winding up the day. So I'll hand the stage over to you.
Thank you. Afternoon, everyone. So I'm Gauthier, CEO of 4C Robotics. And actually, the presentation is no USBL, other than speaking of USBL. But that's the entire point. It's not just no USBL, it's a brainstorming I'd like to have with you about our past years developing technology and trying to servicing the offshore wind market. So maybe I'll start quickly with a small word of 4C. I'm not sure all of you know us. So we are a French-based company. We have offices in Sète, south of France. And we do R&D for ROVs, manufacturing, so we also sell equipment, and service and operation. For the past 2 years now, we have been servicing and leasing our equipment globally. So that's our brand new offices. We've been there for the past 2 years now. Once again, south of France, close to the Sète Harbor, which is an upcoming harbor for Mediterranean wind farms. We now have 2 brand new remote control rooms at the office, and of course testing pool and storage facility. So we are a startup, or at least we used to be a startup, and I like to start my presentation with the adventure we had these past 8 years, of course creation. We really started from scratch with my partner. We went for a first proof of concept, and we just completed industrialization. So we went from 1 prototype to 3 ROVs running, and we'll have now 6 or 7 ROVs running next year. And hopefully we'll complete more than 100 projects, commercial projects, by the end of next year. And to conclude this 4C presentation part, a typical summer we had. I like this slide because it shows how we work and our business model. We are selling equipment, we manufacture our own cameras and vision systems. So we have emerged with our partner IFOMER and Ocean Network Canada, one of the first resident cameras for subsea observatories. So we are more than 2 meters water depth, more 2,000 meter water depth, and the camera will stay in the water for 2 to 3 years, hopefully. We are servicing French wind farms for EDF with the Argos ROV, which I'm about to show. And we are also leasing equipment, so we are accompanying offshore operators with leasing and support technical services. And we have ROVs running now too for Petronas in Malaysia. So manufacturing and sales, service and leasing. So the entire, of course, we know selling services offshore, but the DNA of 4C has been to push smaller vessel or no vessel, and of course you will see a transition towards unmanned vessels and autonomous vessels. So I love to start my presentation by these 4 aspects of the industry. Of course, now that oil and gas is rising again, you need big vessels, so I'm not speaking to some of you who are actually selling vessels and expensive vessels, and that's good for the business, of course. But the vessel cost is probably the most important part of what we are paying when we are working offshore. So we need smaller vessels and to reduce CO2 emissions. There are workforce shortage everywhere. It's not just Norway or Europe, but everywhere. Engineers, technicians. So ideally you need smaller vessels, you need less people offshore. Of course, more and more equipment are needed, especially after COVID. We can see that during COVID, manufacturing has decreased. We must stop production, same for the cars, same for the planes. So we have 2-3 years delays, and now that industries are rising again, there are equipment shortage, which is good once again for the business, and prices are rising again. And of course, when it comes to servicing offshore wind farms, you've got every offshore field, but especially when you're shallow water, you are very, very dependent on the mid-ocean conditions, especially current. There are huge currents in Europe when you're servicing wind farms. So my conclusion is smaller vessels, less people offshore, more equipment, but agile equipment so you can optimize weather standards. Second aspect of it, and that's the end of the introduction, offshore wind is booming from 40 to 300 gigawatts in 10, 15, 20 years. Of course, we can discuss the figures, but what's happening right now in the offshore wind industry is absolutely huge. And so that's what I call the volume effect. And second aspect of it is the repeatability effect. Oil and gas, you have one big field, you have one project, 10, 100 engineers following the project for 20 years. Offshore wind, you have one foundation, all the wind farms are very much lookalike. So you've got similar assets. So I got volume on one hand and repeatability on the other hand, and that's an entry point for robotics. And this is why we believe autonomy in robotics is very well adapted to offshore wind. Oil and gas, of course, you have business cases, you have plenty of companies pushing innovation, but the entry barrier are very high, and in the end, they are all specific projects. Offshore wind, what you do on one wind farm, you can repeat it on every wind farm. So, what do you do when you're working offshore on wind farms? Everything has been presented so far, so that's great to come after you. Of course, visual inspections, not only visual, but non-destructive testing, corrosion, width measurements, also cleaning, and cables. If you do visual, NDT and visual inspections and cable surveys, you cover, I'm not counting UXO surveys and pre-lay surveys, which is more like a survey business, which is actually what you're doing. But cables and visual inspection, you cover like 95 or 99% of the scope of work. So for that, we designed an ROV, one of the most compact ROVs, capable of performing both cable surveys and visual inspections and NDT surveys. The entire idea is to work from light vessels. And working from light vessels will allow us to push autonomy and working remotely, because of course we have less people offshore. So this slide, the product approach is really the conclusion of my introduction. We are pushing, of course we can work from big vessels, we can work from fixed platforms, but the entire idea is trying to push and to sell that to operators to reduce vessel size. And it works even more if we don't have USBL, or if you have reduced service spread on board. USBL, when you do off-class ROV, you have the vessel price, you have the ROV crew price and ROV cost, but you also have survey spread cost, which is probably more than the ROV itself. So what we are really trying to push is to have all the survey equipment compacted inside the ROV, integrated, and dive with as less positioning sensor as possible. Of course, that's an objective, I'm not saying it's always the case, and USBL is necessary, especially when you dive too deep. What we have been pushing as well is diving from CTVs, crew transfer vessels. So I think we are, I know we are not the first one, but we are one of the first companies who have really sold regular commercial services from CTVs on a regular basis. So we did that with 2 or 3 wind farms operators now. And we dive without USBL, we dive with just 2 or 3 guys offshore, depending on the launch and recovery process. And the positioning, and I will speak about positioning right after, is coming inside the vehicle. So we are integrating everything. So there is no surveyor on board. The business case of it, from a standard vessel, so I'm not speaking of a big FSV vessel that Equinor would use to install Christmas trees, of course, but the standard survey vessel you have offshore in the North Sea or in the Baltic Sea with a light work-class ROV and survey spread, who can service wind farms, compared to the CTV approach. That's of course, you can still challenge the figures, but the idea is it is at least 2 times cheaper to work from CTVs, and it could be even 2 times cheaper to work from USVs, but that's coming after. So that was some kind of introduction. Reduce the size of the vessel, trying to put all the smart equipment inside the ROV, and try to derive a business case from that. So I think now, after 2-3 years offshore, commercially, we have validated this business case, so now we need to deploy more and to improve the technology. So now I come with autonomy. Why autonomy, or is autonomy needed once I validated the business case from the small vessels? So I'm happy to see this slide, because it's been a long time now. We validated the first autonomy use case, or at least technologically speaking, with Deep Ocean and Aker BP. It's been 3 years now. So that's a big vessel, so it's not a good example, but what I want to show is autonomy is available on the market, or it could be available on the market when you put the right resources. So we are not the only one, and I won't brag about that. We are not the first company doing autonomy, of course, with the Saipens and not sharing a lot of big guys. Plenty of people know, and same for ADVs, right? And Kongsberg, people know how to perform autonomous flights around structure. It's harder when you go close to the structures, because positioning is really a challenge. So autonomy from a big vessel with a USBL is feasible. Autonomy from a small vessel without USBL is a challenge. So that's a typical example and typical equipment spread we have mobilized for EDF with Louis Dreyfus Armateur last year. So of course, there are all these operational aspects we need to improve. It's not only autonomy and algorithms, it's about launch and recovery, HEC procedures, cranes, lift certificates, because CTV might not be qualified for ROV operations. So you have the entire engineering to be re-evaluated with the operator, and also the mooring aspect of it. The idea is because when you dive in free flying mode with an ROV, you have the risk of the tether to be catch in the propellers, of course. So the idea is to moor the CTV directly to the foundation, so you switch off the engine and you can dive safely. But of course you have current, and for example in Saint-Nazaire you can just dive at low tides, you can dive 2 to 3 hours maximum before the current goes up. So it means on 24-hour basis, because you don't have usually in wind farms you just work 12 hours a day, but because you have current, you just work 6 hours a day in 2 or 3 dives. So once again, I'm comparing a big vessel IMO approach compared to a CTV, where just 1 hour and a half, 2 hour operation, 3 times a day. So of course you need to be super agile, and this is where autonomy has a meaning, because you can continue the dive exactly at the exact spot you stopped it. So we validated autonomy again, and that's my transition to positioning. We embark on the ROV, we have an embedded IMS, XR IMS, Rovin's DVL, we are totally IMS agnostic, we could embark any market-leading IMS, and we can perform autonomous flights. So it's accurate enough, you do a GPS fix on the first foundation and you dive, and after 2 to 3 hours of dive, you still have an acceptable position. But this is GVI, General Visual Inspection. What about CP contact? What about cleaning? What about NDT intervention, like structure contact? That's a different game. And that would be the same, by the way, for work class operations. Work class, it's in the name, you need intervention, so you need pilots and arms and manips, so you need real-time communication. So speaking about autonomy, it's easy to do when it's GVI. What about autonomy for contact and work, actual work? Autonomy can also work for cable survey, so we just did that's the fun stuff. A cable survey, so cables are just laid in the field, they are not buried. And they had the as-led profile, which are the small dots you can see. And the green part is the correction we had without USBL. It's a purely IMS DVL cable survey. And we did 2 tests, one with the GPS fix or RTK correction. So the ROV tags in water with the GPS IMS initialization. And one with no RTK correction, just a standard GPS. And that's the second aspect. If you do no RTK correction, the pass, I think that's 0 to 10 meters. So what you see in red is the error of the survey. So of course you can do a survey without USBL, but you will have a plus 10 something error in the survey. So that's not acceptable. So of course, pushing this USBL free from light vessel requests extra positioning stuff. And that's actually my transition. As a conclusion, you can work fast when you do GVIs, General Visual Inspection, thanks to autonomy. It's been validated offshore. We've done several runs. You work faster, the image is super stable. But you need a positioning. At the end, after 1 to 2 hours, you drift. Any IMS, any DVL will drift, especially if you have echo on the structure. You can't go in contact with the structure, and to be honest, CP measurements and contact with the offshore wind farm is half or 2/3 of the job. So GVI is very quick to perform. What you need to do is get in contact with the structure and clean the structure before you actually measure samples. And same for free fly operation. If you do free fly, you need some rigor on the deck to manipulate the tether. So what about autonomy? Of course, the ROV is autonomous, but if you have 1 guy, 2 guys on deck, why don't we have an extra pilot? And autonomy doesn't mean nothing. So that's a conclusion. It's obvious bullet points I'm showing here. Most of you working in the ROV business probably have the same feeling. So we kind of shifted our priority. I'm not saying shifted the roadmap, but shifted the priority. And we have pushed what I call smart and remote ROVs. The priority is to have the expertise and the video recording and the data recording offshore. That's obvious for most of you now. Most of the survey companies here have remote survey offices, so I'm glad we are all following the same trend. For ROVs, you have a challenge which is real time. I know in Norway, probably one of the first and only country in the world where you have 3G everywhere. So for you, having real-time comms on the platforms is not something new. But most of the fields we operated in Europe and Malaysia, Brazil, Africa, they have no network. So now we have Elon Musk and Starlink, which is good. But to have the ability to pilot an ROV with a 3G connection or satellite connection requests like 100 mil, 200 milliseconds. If that's more than that, you can't pilot anymore, and that's supervision. And to allow this remote supervision, this is where the smart part is coming. Of course, it's a piece of autonomy, but basically it's a dynamic position. What you want to do if you release the joystick, the ROV is stable, you know where the ROV is, you have a situation awareness, rather than taking a joystick to go 1 meter forward, 1 meter backward, you use arrows, and when you retrieve the arrows, there is no movement anymore, and you have a stable position. And that's what we've been developing and now running on the field. But of course, dynamic positioning requests position. So next problem, very quickly on this slide. Once again, we have no GPS subsea. The idea is to get rid of USBL systems because it's very expensive and we need a surveyor on board. And our goal is to have a ready-to-dive ROV with no surveyor, just one pilot, one supervisor. Of course, we have the INS, we have the DVL. I'm going very fast on this slide because you're survey experts, so probably more expert than I am. So you know that INS are drifting, bugs, and that's an excellent complement to the voice presentation. Very impressed with the voice results. You have images, like your brain and your eyes, you have images. And images now can allow you to navigate and to position it yourself. So we have deployed and we have conceived a serial camera. I'm telling you right away, it's not a 3D reconstruction camera. I don't know if what voice and VAST and all the other 3D systems, they are much more advanced than we are. Absolutely no brag on this part. But we have pushed a navigation system. It's not a 3D reconstruction system, it's really a compact, real-time navigation system. So we call it a VVL, or Visual Velocity Log. So it would behave exactly as a DVL feeding the IMS, right? It's not a 3D reconstruction. You have a camera, as soon as it sees a texture, 10 times a second, 20 times a second, it feeds the IMS. End of story, exactly like a DVL. We don't want to speak about 3D, we don't want to speak about SLAM. We have plenty of solutions existing in the world. What we are doing, and that's our job at 4C, is to integrate the most compact ROV with no surveyor on board, no survey system on board. We want everything to be plug and play. So you plug the IMS, you plug the VVL camera, end of story, you have your position. Every data to be outputted, the data recording, the CT values, 3D models, these are the client's data. My job is to give the ROV fully compact. So just a couple of images. We really started from scratch. Probably there are plenty of similar aspects to the competitors. I'm totally aware of that. But we really, compared to the cameras existing on the market, we had to, and we are used to manufacture subsea cameras because we've been selling cameras for the past 6-7 years now. We really started from scratch on both CPU aspect, camera, and connection aspect to be able to have real time, but real time is milliseconds and not more. And especially with the heat, you know that image treatment, that's a good example of how far we had to go. Image treatment is requesting a lot of computer resources, so the computer are heating, and when the metallic structure is heating, you have some metallic distortion or modification. So we work with ANVAR, which are very expensive materials, very heavy materials, to make sure that if the temperature of the camera is increasing by 10 or 20 degrees, you have absolutely no movement. So it requires very fine calibration. And it allows us, so I'm just sharing first tests. We've been running with the camera for the past 6 months now. It allows us to get centimetric error in real time. When I say centimetric error, is when this system is feeding an INS and you navigate for a couple of minutes. I'm not speaking about post-processing, 3D reconstruction. In real time, you plug the camera to the INS, you drive 10 minutes, 1 hour, and then in the end you just have an error compared to the exact, to the accurate solution. So what we've been doing so far, that's an image of the ROV. That's some image of the INS and the DDL, and you've got also the titanium housing with the camera. So everything is compacted now. We have very promising preliminary results. We started qualifications with a French oil and gas operator, quite easier. And we hope to be one of the first direct INS interfacing visual navigation system. To be honest, I'm pretty sure that competitors could do it. I don't know if it's request development or it's plug and play. What I can say is our equipment is really dedicated to visual navigation and INS feeding. And once again, our priority is to feed the INS so the aero can dive from light vessel without position. So once again, you mobilize your equipment, you do INS fix on deck, you place the ROV in water, and you have a full DP mode with a map, and you have a position for the rest of the day. And that's actually my last slide, just to mention. Today we have the Argos ROV running, so soon we'll have 6 or 7 ROVs. The visual navigation is coming, so Åkrehamn has been accompanying us. Of course, we are looking at the USV aspects. The CTV is just a transition. I'm a huge believer in the USV business case. And everything close to residency or battery powered ROVs is another story. We are looking at it. We have national grants, but to me, that's a different market. Thank you very much.
Thank you, Gopi. That was very interesting and bang on time. Are there any questions from the audience at all on that subject before we crack on with our last presentation? Anybody? Okay, thank you very much. Oh, sorry, there is one. Go for it.
Very interesting. Do you do the visual odometry yourself, or is that done by INS?
Yeah, well, the cameras grab the images, everything is processed inside the housing, and I think we work between 10 and 20 FPS, and 20 times a second we send some kind of NMEA message to the INS. We have a cable between the camera and the INS, exactly like a DVR. So of course what we need, and this is what we have been starting with Excel, is how to calibrate, because you know Excel is selling this RTS as well, compacted and pre-calibrated INS DVL, so we need to do the same with the camera. And of course, when you look at the error we want to achieve, we need a super accurate calibration.
Okay, thanks. Okay, any more questions?
Thank you.
Okay, thank you very much for your time.
Come on.
Okay, I think we're probably maybe a little bit saturated on the industry presentation, so I think someone once said something completely different. Einar Torgsik is going to talk about Project Moxon. Is that correct?
Yes.
Good.
Hello. Now I'm the only thing that stands between you and the bar. That's very nice to be last man on stage. What I want to talk about is the project that I was a part of starting together with the other companies' logos in the bottom there. Attendees, the power port in the north, a very marvelous type of saying, but there is a lot of truth in it. What I want to try to do with this presentation is that to connect business development to technology development and try to inspire you maybe to say that I want to join such a project locally or with us here in the Attendees. And this is a legacy, basically, that we are working with now that started 3,000 years ago in this port. And what I first have a little bit of the attendees, all the logos that you see in the bottom, those were those who initiated the project. First of all, with the project leader, Stavanger Maritime Museum, which is here today. And when you do the mingling afterwards, try to find Arild. He's the one with the very nice shirt. So he can tell you more about this. There were 2 private companies that attended or started this project, which was GeoPlus, which invited us in Saga Subsea. I was then in Saga Subsea. I'm not anymore, I have left the company. So I'm basically here as an independent freelancer consultant representing this project. However, GeoPlus is also here today. Now Omega Subsea. So they have joined into Omega Subsea. So Halja and Hanne, I think it's nice that you also show that you are here. So, and I will also say that as far as I believe from Hanne, at least, and Halja, is that RTS also contributed a lot now to the project and started to get into it. So people are interested, people want to do this. That was the introduction to it. What I want you to notice, the PowerPoint, is first of all the vessel. This is a very typical vessel that did trade in this area, traveling from the northern Europe up to Bergen and the northern Norwegian areas to trade fish and so on. The fuel of this vessel was wind. They fueled the vessel with wind in the sails to do. So basically, you harvest wind, same, so the ecosystem is going in circles, going back to what we want to do today. To harvest wind to fuel the trade that we're doing. Shipbuilding techniques. You are actually you're actually in an area now where shipbuilding techniques has been developed through thousands of years. The first vessels that sailed over the North Sea was built in this region, and the first Scandinavian vessel, the Northern Europe vessel that started using sail, was basically invented in this region. So harvesting this and using business development in this area, it's the same thing. So RTS and many of the companies that have been on stage a lot is survey. This is probably, or as far as documented now, the first survey mapping of this area. Done in at least that is documented. You can see where RTS is on the map today. And basically, then it was done by pen, now new technology. You're also in the actual area now where Norway got its name. Because this is where you sail from Northern Europe up to the north, the way to the north, Norway and Norway. So this is where the highway basically started, going north. This is where we got our name. And again, this with trying to have a project like this, adding Stavanger Marine Archaeology Museums, the private companies, trying to connect this in the marine archaeology project to create new technology, I would say have been a very great success, and we would like to continue this program going forward by letting history lead our way to learn from our heritage to how to develop in sustainability with basically nature. The project stakeholders in this. The outer circle is basically the attendees, while the inner circle, it kind of tells us it tells us history. What do we want to know? What do we want to get out of this? What they did. What did they do previously? How did they do it? And why did they do it? That gives us an idea of technology development, what we want to be looking for, and to learn why they did it. I like to use the upper pictures. It's a core sampler. Fairly easy tool, but nevertheless, Stavanger Maritime Museum, they really wanted something that could penetrate deeper, get longer core samples to see what they could do. That was a challenge that was in that. It was a fairly easy tool, but given to Subsea as a challenge to see if we could just make something to penetrate deeper and get core samples up. That piece of asset was added to the rental tool pool, and we got asset out of it to actually use in the commercial market. While the things coming up could be researched, piece of wood, where did it come from? Why was it there, basically? So using those type of combination between museums and marine archaeology into business development have showed out to be good for all the attendees. And what has the project contribution been at the end of the day? Actually, it increases local residential attractiveness. It's good for the local community. It's good for the local governments to actually get these projects locally. They should be supporting them, and they do. It's incentives for technology developments, such as mapping in new ways, trying technology. Private companies could come in with maybe some of the things from the presentations that we've seen here today, to test it, to do mapping, to do penetration in the soil, to find new things that we haven't seen before. And it also creates quite an interest in our trades. I've been working, or put it another way, I've been trying to explain to my mom for 20 years what I do offshore. She sees orange boats and big yellow things on the seabed. But so it kind of, this creates interest that you can do something else underwater and do other trades and combine history and technology development and subsea equipment and all the things around. So schools, all ages, and up to, what can I say, masters, bachelors, PhDs, so on, they could be a part of this project as well. So it creates an open door, and it creates access, so the students can actually get in and learn. Also, you get to understand history, and not only what they did, but why they did it, and create sustainable business development, try to understand why things are as they are. And it's also good marketing. As the pictures show on the slide, it's good marketing for the companies to be a part of such projects. So I will encourage everybody to speak to Aval and try and see, and also maybe speak to local museums and local where you are from to make this a part of your business development one way or the other. And that was it for me. So, thank you very much.
You caught me off guard completely. I thought you were going to go for the long version, because we have got quite a bit of time. So are there any comments from anyone locally, especially regarding the origins of Norway? That was interesting. No, everyone wants to get back outside. Everybody wants to go to the bar. So the bar is going to be open a lot earlier than planned by the sound of it. Tora would like to.
Just a little bit about it, because as you mentioned very briefly, Attendees has a little interest in this for the future. I think it's quite cool that we are using technology to find out more about this. That's what it's figured to be as well. And I think we have had a discussion about how quite soon within pizza area. So.
Thank you, Joel. So we do want to come to the point because we're going to wrap up now, so maybe some final words. I just would like to say thank you for everyone coming today. It's a really big turnout. It's been six very interesting presentations. As I mentioned, the first guy, Runa, wasn't able to attend, but he has confirmed on text message that he will be in Bergen, so I would thoroughly recommend that everyone be in Bergen in a month's time. And I haven't spoken to anybody about the offshore survey course at his school. Please come forward, contact me on the phone or email. I really do need assistance from the industry to make that happen. So I'm going to pass it back to you now, and then you can wrap up.
Okay, yeah, thank you for that. No, it's been a good day. I'm quite happy, very happy with the attendance, with all the people coming. We had a long negotiations about the weather, but it turned out quite well in the end, so that's good. There will be served food now 5 o'clock, I think. There's food come up, so there's like food from 5 to 7. And then when that is done, the food is done, then I guess, at least from the people that have been here before, they know the routine, and it's about mingling. It's all about the network. That is basically why we are here as well. Exchange experience, understand of new technologies in the market, and make new friends and colleagues. That's why we are here. So I'm very pleased with what we have achieved here together. It looks like we've had a good program, at least on the response from audience. Very nice to see new people, and well, I don't have too much to say actually. I'm happy, hope you're happy, and we're going to make you even more happy. Go for it.